In this next video, we're just going to keep moving along our formula sheet. So in the first set, we covered basic identities. And now in this video, we're going to move on to Pythagorean identities. So Pythagorean identities obviously come from Pythagorean theorem, and so they've set up a right triangle and looked at the relationship between, sine and cosine as the legs and yada yada yada. And what they came up with is sine squared x plus cos squared x equals 1. Then they took this identity and they divided everything by sine squared x. So sine squared x divided by sine squared x is 1. Cos squared x divided by sine squared x is cotan squared x. And 1 over sine squared x gives you cosecant squared x. Then they did that whole thing again, and this time they divided by cos squared x. So sine squared x divided by cos squared x is tan squared x. Cos squared x divided by cos squared x is 1. So they just changed the order to make them look the same. And then 1 divided by cos squared x is secant squared x. So those are your three kind of basic Pythagorean identities, but you can also do iterations of these. So don't get stuck on them being, that sine squared x plus cos squared equals 1, because you could also rearrange this to say that sine squared x equals 1 minus cos squared x. Right? So if you subtract cos squared x from each side. Or you could say that cos squared x is equal to 1 minus sine squared x. Or you could be even trickier and you could subtract 1 from each side and then move the other trig expression over. So for example, you could say that cos squared x minus 1, so if I minus the 1, is equal to negative sine squared x. And by that same token, you could say that sine squared x minus 1 is equal to negative cos squared x. So you can do lots of different iterations of these basic Pythagorean identities. So let's see how we can use them. Well, again, if I ask you to simplify, hopefully you look at this and you're like, well, everything's sines and cosines, so I'm just going to distribute. So we're going to multiply and get 1 times 1 is 1. And then we've got 1 times negative cos x is negative cos x. Cos x times 1 is positive cos x. And then positive cos x times negative cos x is negative cos squared x. Always look to see if you can simplify. These are conjugate binomials, so they're going to end up as a difference of squares. So negative cos x plus 1 cos x is gone, and I'm left with 1 minus cos squared x. And if this had been the first video in this lesson, I would have said, great, you're done. But as we build on, you might go, oh, but this isn't the answer in the back of the book. The answer in the back of the book is sine squared x. Why could that be? Well, what you'll start noticing with these is anytime I see two trig expressions, two trig terms that are squared, or if I see a 1 with an expression squared, I think Pythagorean identity. So I go up here and I go, oh yeah, if I rearrange this basic Pythagorean identity to 1 minus cos squared x, it would equal sine squared x. So I can now make this expression that is a binomial into a simpler monomial. So again, it's really hard to find homework, so it goes steps at a time. But this one should belong in the Pythagorean theorem section or Pythagorean identity section, and the answer will be sine squared x. So now pause the video and maybe give this one a go, or, maybe not. So there's a few ways of approaching this question. When I look at this, like the first thing I saw is, oh my goodness, I want to change everything into sines and cosines because that's what I was taught in the last lesson. But I told you at the end of the last lesson, don't get stuck on that. What if I distributed it as is? What would happen? Well, I'd get cosecant x times cosecant x, which would give me cosecant squared x. And then I'm looking at this being like, ooh, this is going to be a binomial bracket, right? Conjugates. That's end up as a difference of squares. I'm going to multiply the cosecant x through to the cotan x and get cosecant x cotan x. Then I'm going to multiply the negative cotan x by the cosecant x to get negative, and I'll just write them in the same order. So cosecant x cotan x. And then negative cotan x times positive cotan x would give me negative cotan squared x. Now again, my middle terms go away, and I'm left with cosecant squared x minus cotan squared x. which again, as soon as I see two terms that are squared, I always think Pythagorean identities. So I go up here and I'm like, could I change this identity around so that I could replace cosecant squared x minus cotan squared x with something? Well, if I do this and I subtract cotan squared x, I get cosecant squared x minus cotan squared x. So this can equal 1. Great. Now, I do want to point out that what if you were someone who was like, oh, but Karen, I really do like changing everything to sines and cosines. What would happen if I did that? Well, let's do it. So cosecant x could be 1 over sine x minus cotan x. I'm going to use the quotient identity to say that it is cos x over sine x. If anybody's struggling how to remember which one is which for cotan and tan, cotan, because it starts with the coat, the cos goes on top, whereas the tan, it's always the sign on top, in case you get sick of flipping to your formula sheet. And then again, the cosecant x would be 1 over sine x, and the cotan x would be plus cos x over sine x. So if I multiply this through, I get 1 over sine x times 1 over sine x, which is 1 over sine squared x. Then I get 1 over sine x times cos x over sine x, so I'm going to get plus cos x over sine squared x. And then keep going, so I'm going to go cos x over sine x times 1 over sine x, so it's going to be minus cos x over sine squared x. And then lastly, I'll have minus cos squared x over sine squared x. Then again, because it was two conjugate binomials, it's going to go to a difference of squares. So I'm going to get rid of those middle terms, and I get 1 over sine squared x minus cos squared x over sine squared x. Oh man, math is so fun. So I could now change these to cosecant squared x minus cotan squared x and be right up here. Or something that we're going to do in a little bit, just to wow you, is that these have common denominators. So I could say that this is a sine squared x on the bottom, and on the top I'd have 1 minus cos squared x. And then again, when I see a 1 and a squared trig function, I always think Pythagorean identity. So we've already seen this one, but 1 minus cos squared x is equal to sine squared x. So I'm going to replace this with the sine squared x over sine squared x, and then I get 1. So regardless, my answer is 1, but it was two different ways of getting there. And I don't know if you can tell, but I love this. I think it's so fun. And then maybe some of you are sitting at home and just being like, oh, I'm going to hate this, aren't I? Well, you got to find the joy. So if you enjoy playing with math, these are fun because there's no real goal except just to make things simpler and to play with things. And I treat them like puzzles. It's like, oh, I've got all these pieces that I can put together. And if I put them together this way, I get this. And if I put them together this way, I get this. And in reality, I get the same thing. So, I did this one in 1, 2, 3 lines. And I did this one in 1, 2, 3, 4, 5, 6 lines. I got the same result. You're going to find the joy in the journey or you're going to hate it. So lots of rooms for error, but just go with it. Okay, so last one here is this one over here. So I always say, again, if you see a Pythagorean, if you see a cos or a sine or a tan or a cosecant, anything squared and a 1 or 2 squared functions, I always think Pythagorean identities. What is with this one though? So some of these ones I pulled from some stuff we're going to see later so that when you see it later, you'll be like, oh yeah, I can do this. I feel confident. So don't feel like if you saw this right now, you'd be like, I can do it. 1 over cosecant squared x is not something that we have seen very often, but we have seen one like this. If we look at our cosecant x, or even our cosecant squared x, we always say that cosecant squared x equals 1 over sine squared x. But remember here where I said that tan x could be 1 over cotan x? Well, same thing here. Sine squared x could be 1 over cosecant squared x. So I could, in here, say that cosecant squared x, well, I just want to start the sentence again. 1 over cosecant squared x, so 1 over cosecant squared x could equal sine squared x. So this is sine squared x minus 1. Again, if you see that squared and you see a 1, think, is there a trigonometric or Pythagorean identity that I could use? So sine squared x minus 1, oh look, we already said that it could equal negative cos squared x. So we're getting into the meat of this stuff. You're either going to be starting to hate me or you're going to be like, oh, weird, but kind of fun. We'll see.